Good day everyone. Today we are going to present you a regression analysis by using both Microsoft Excel and the R programming language. Suppose that we have a data table of the market value for the assessed value of a land. We want to check the accuracy of the assessed value that made by the city assessors by performing a regression analysis to this data. For the prerequisites of using both Excel and R for regression analysis, both Microsoft Excel and GNU R or R Studio need to be installed. In addition, an extra add-in called Analysis Tool Pack is required in Microsoft Excel and none is needed for R. We have to ensure the data is correctly imported into Excel and R. Then we can safely perform our regression analysis with the functionalities in both software. First and foremost, we will get started with Microsoft Excel. In Microsoft Excel, under the Data tab, we choose the regression function from the Data Analysis menu. After input the required information, such as the range of independent variable and dependent variable and the output area, we will finally have the output in Microsoft Excel. From the previous output, we have obtained the coefficient value of access dependent variable, which is 0.4156. In order to test the significance of coefficient of access value, t-test for individual coefficient is carried out. From the output, we can see that the p-value of t-test is less than the critical value. Thus, we reject the null hypothesis. This means the coefficient of access value is significant in the regression model.
Besides, we also test for the overall significance by using f-test. From the output, we can observe that the p-value of the f-test is less than the critical value. Thus, we reject null hypothesis. This concludes that the overall regression model is significant. The t-test and f-test results show the assessed value that made by assessors is an important factor in the determination of market value of the land. In addition, correlation test is used to check the significance of the population Pearson's correlation coefficient between two variables. In Excel, these statistic values are required to be filled manually one by one to obtain the result of correlation test. It is inherently easier in R, as we will see later the result. From the result of the correlation test, we can see the p-value is less than the level of significance. Hence, we reject the H-null. This means the assessed value and the market value is significantly correlated to each other. So, from the summary of output, we can see that the R-squared value is equal to 0.376. This means that the assessed value can make a prediction with an accuracy of 37.6% to the market value. This result shows that the predictor variable is weak to predict the response variable. Hence, we suggest to add some relevant variables into the regression model in order to increase the accuracy of the prediction.
For the R counterpart, most of the analysis results are the same as what outputted by Excel. Thus, we'll go through at a faster rate on some common results interpretation part. In R, after all the data has been imported, the Rn function is called with the imported dataset as second argument. The first argument is the formula of the regression model. In our case, is market depends on assets. After we look into the summary of the regression model, the similar output to Excel will be produced. The coefficient of dependent variable excess of 10 from the output is 0.4153, which is used in the test shown. From the result of t-test, since T p-value which represents the p-value is less than T alpha, which is the level of significance. Now hypothesis is rejected. So the coefficient of excess value is significant to the regression model. For the f-test in R, from the output we can see that the f value is less than the level of significance, which is represented by f alpha. Thus, we reject null hypothesis. This concludes that the overall regression model is significant.
Correlation tests are: Step 1 is hypothesis testing. H0 is equal to 0, H1 not equal to 0. Step 2, test value. Core value is less than correlation p-value. Step 3, critical value. Core alpha less than 0.05. Step 4 is a result. In R, only the core test function is needed to obtain the result, which is relatively easier than what we did need in Excel. From the result of the correlation test, core p-value is clearly less than the level of significance of alpha. Hence, null hypothesis is rejected. This means the excessive value and the market value is significantly correlation to each other. Now, let's go to C summary function. In R, from the summary output, we can see that the R square value is equal to 0.376. This is the same with what Excel shows. The conclusion is also the same with Excel, which means the excessive value can make a prediction with the accuracy of 37.6% to the market value. That's all from us. We hope you enjoyed this video and have a nice day. Thank you.